You, myself, Dr. Majid Khan, Associate Professor, Lieutenant Dr. J.D. Pawar, College of Pharmacy, Kalwan, Nasik. I welcome all of you in this chapter of antibiotics. So, in this video or in this lecture, we will cover tetracycline antibiotics. So, among the most important broad spectrum antibiotic are member of tetracycline family. Now, in such compound, tetracycline, tetracycline, maclocycline, methacycline, doxycycline, maclocycline, minocycline, oxytetracycline, chlortetracycline, and democycline have been introduced into the medical use. The important member of the group are the derivative of octahydronaphthacene, which is a hydrocarbon system that comprises 4 annulated 6-membered ring. The group name is derived from this tetracycline system. So here there is a general structure of tetracycline is given. So this structure is called as octahydronaphthacene. So there is a continuous 4 ring attached fused. So it is a naphthacene, but some position there is a saturation, therefore it is called as octahydronaphthacene, which is a 4 annulated 6-member ring system, but it is generally called as tetracycline. Tetra means 4, cycle means 4 cycle, so generally it is called as tetracycline. So here numbering pattern is also given. So as we see, start from the carbonyl, carbon 1 2 3 4, then 5, then 5A is there, just neighbor to 5A, then 6A, 7 8 9 10, then there is a 11 12, 11A and then 12, and number of example is given. For example, chlortetracycline, oxytetracycline, tetracycline, then democycline, depending upon the various group on 7th, 6th and 5th position. So mainly tetracycline having the chiral center at the position carbon 4, carbon 4A, carbon 5, carbon 5A, carbon 6 and carbon 12A. So these are the chiral center depending upon the substitution. So there are 6 chiral carbon, but oxytetracycline and doxycycline each with 5 alpha hydroxyl group, it has 6 asymmetric center. So only oxytetracycline and doxycycline having the 6 asymmetric center, but the other drug which lacking the chirality at carbon 5 have only 5 chiral center. So only 2 drugs, oxytetracycline and doxycycline, having the 6 chiral or asymmetric center. Remaining drug having only 5 chiral center. X-ray diffraction confirmed that conjugated system exists in structure from carbon 10 to carbon 12 and from carbon 1 to carbon 3. So from 10 to 12 there is a conjugated system is alternate single double bond. So as we see at carbon 10 single double bond is there up to the 12 position. Similarly 1 2 3 there is a single double bond is present. So it is a conjugated system at position from carbon 10 to carbon 12 and from carbon 1 to carbon 3. Below there is IUPAC name is given. It is a IUPAC name for the third drug, that is tetracycline. This various drug, there is a third drug tetracycline. IUPAC name is given 1 4 4A, 5 5A, 6 11 12A octahydro, 3 6 10 12 12A pentahydroxy, 5 time hydroxy group, 6 methyl, 1 11 dioxo, that is ketonic group, 2 naphthacene carboxamide. Then tetracycline are amphoteric compound. Amphoteric compound means it behave as an acid as well as base, forming the salt with either acid or bases. In neutral solution, Tetracycline exists mainly as a zwitterionic species. Zwitterionic species means which having the both charge, positive as well as negative. The acid salt which are formed through the protonation of enol group on carbon 2 exist as a crystalline compound that are very soluble in water. So here on second position there is a amide group is present, C double bond O NH2. So this group is utilized for making the acidic salt and it is very soluble in water. Amphoteric antibiotic will crystallizes out of aqueous solution of their salt, however unless stabilized by excess of acid. The hydrochloride salt are used most commonly for oral administration and usually are encapsulated because they are bitter in taste. So by using NH2 group at position 2, acid salt is prepared. The most common acid salt is hydrochloride salt. Water soluble salt may be obtained also from bases such as sodium potassium hydroxide, but they are not stable in aqueous solution. Then properties of tetracycline. So first property is epimerization. Tetracycline have ability to undergo epimerization at carbon 4 in solution of intermediate pH range. This isomer is called as epitetracycline. Under acidic condition, an equilibrium is established and consists of approximately equal amount of isomer. The 4 epitetracycline have been isolated and it show much less activity than natural isomer. So at intermediate pH, tetracycline undergo the reaction called as epimerization, means there is a formation of epimers. So what do I mean by epimer? Epimer means when there is a change in configuration at particular position. So it is a reaction given how the tetracycline form the epimer. So if you see the reaction, just follow the arrows for the reaction. So in first step there is a remole of hydrogen, bond shifted to ring side, that is double bond. Then this double bond of a ring is shifted here, that become O minus, and then hydrogen attached here, it become OH like this. So here there is a OH. Then tautomerism, as shows by arrow, hydrogen shifted here, this bond shifted here. So it forms this type of product. Like again there is a reverse reaction, hydrogen is removed, this bond shifted here, this bond shifted here, and this bond shifted here. There is a formation of this negative charge. So here there is a negative charge carbanion formation. Last step is protonation. So here there are two chances of protonation from the above the plane and below the plane. So when there is a attachment of hydrogen from above the plane, then there is a formation of natural tetracycline denoted by solid line. If hydrogen addition or substitution of hydrogen is taken place, then it is from the below the plane, so like this dotted line. So it forms 4-epitetracycline. So if you see the natural tetracycline and 4-epitetracycline, only the difference is position of group above and below the plane. In case of natural tetracycline, hydrogen is attached through the solid line, while dimethyl amino group attached by the dotted line. But here in case of epimer, opposite situation is there. Dimethyl amino group attached through the solid line, hydrogen attached through the dotted line, means alpha position. So it is a difference between natural tetracycline and 4-epitetracycline. So in short, tetracycline undergo epimerization reaction and it forms the 4-epitetracycline isomer. So in intermediate pH, this is in equilibrium, pH equilibrium, that is equal amount of these both the compounds, but it is shown that 4-epitetracycline is less effective than natural tetracycline. Second property, dehydration in presence of acid. Strong acid and strong base attack tetracycline with hydroxyl group on carbon 6, causing loss in activity through modification of C ring Strong acid produce dehydration through the reaction involving 6 hydroxyl group and 5A hydrogen. The double bond thus formed between position 5A and 6 induces a shift in position of double bond between carbon 11A and carbon 12 to a position between carbon 11 and carbon 11A, forming inactive anhydrotetracycline. So here in presence of acid it undergo dehydration. So we just follow the arrow for the mechanism. So here there is this one is 6th position which contain hydroxyl group. So this hydroxyl group is removed, bond shifted, it become double bond, and this hydrogen is removed, total removal of water molecule. Then here again hydrogen is removed, this bonded shifted here, this double bond shift here, it become O minus, and then hydrogen attach here, it become OH. So this the final product is anhydrotetracycline, which is a inactive compound. So here the important point is this in this reaction 6th position hydroxyl group is involved. In SAR we see the importance of this hydroxyl group. So in presence of acid, tetracycline form the inactive compound anhydrotetracycline. In this reaction, hydroxyl group on 6th position is involved. Similarly, in case of bases, bases promote reaction between 6 hydroxyl group and ketonic group at 11th position, causing the bond between 11 and 11A to cleave, forming the lactone ring. Lactone ring found inactive isotetracycline. So here again there is the involvement of this hydroxyl group which is on 6th position. So in presence of base, so he just follow the arrows. So here first there is a deprotonation, so it become O minus. Then this O minus attack to this carbonyl carbon, and there is a formation of between oxygen and this carbonyl carbon like this. It become O minus. Then tautomerism. So here tautomerism means this hydrogen shifted to here and this double bond shifted here like this. So it is a tautomerism. Then there is a again rearrangement, O minus converted double bond. This bond is break and here there is a negative charge formation, that is carbanion like this. Then this carbanion after protonation give, that is it give isotetracycline, which is also inactive compound. So here also there is a involvement of 6th hydroxyl group. So in presence of base, tetracycline undergo dehydration and it form isotetracycline, which is inactive compound. And in this dehydration reaction in presence of base, again hydroxyl group of 6th position is required or involved. So in both cases, in presence of acid, in presence of base, tetracycline form inactive compound, and in both the reaction hydroxyl group of 6th carbon is involved. These two unfavorable reactions stimulated research that led to development of more stable and longer acting compound 6-deoxy tetracycline, methacycline, doxycycline and minocycline. So it is a dehydration in presence of acid and in presence of base. Then there is a next property, that is chelation. The acidic function of tetracycline are capable of forming salt through chelation with metal ion. The salt of metal ions such as Fe2 plus, aluminium, calcium, magnesium are insoluble at neutral pH. The insolubility is not only inconvenient for preparation of solution but also interfere with the blood level on oral administration. So here there is a simply complex formation, it is a M for metal. So here there is a complex formation between the tetracycline and metal. The tetracycline are incompatible with co-administration administered ion rich antacid and with hematinics, and concomitant consumption of dairy product rich in calcium ion is also contraindicated. So tetracycline is contraindicated in presence of antacid and hematinics and dairy product which contain these metals. Further, the bone of which teeth are most visible are calcium rich structure. So here there is a accumulation of tetracycline in proportion to amount and duration of therapy when bone and teeth are being formed. As the tetracycline are yellow, this leads to progressive and permanent discoloration in which in advanced cases the teeth are even brown. To avoid this, tetracycline are not normally given to children once they are forming their permanent set of teeth at the age of 6 and 12. Tetracycline are painful upon intramuscular injection. To deal with this, injectable formulation contain EDTA and are buffered at acidic pH where chelation is less and water solubility is higher. When concomitant oral therapy with tetracycline and incompatible metal ion must be done, the ion should be given 1 hour before or 2 hours after the tetracycline. So in presence of metals, tetracycline form the chelate. So therefore it is not given along with the antacid and hematinics which contain metals. Similarly, in our body, teeth and bone is made up of calcium. So tetracycline also react with this calcium and it causes yellowish of teeth. Sometimes there is a brownish teeth. Therefore, tetracycline is not given to the children until their permanent set of teeth is not formed. And intramuscular injection is also painful. Therefore, it formulation contain EDTA and are buffered at acidic pH. So therefore, when tetracycline therapy is required, the metal ion formulation is given before the 1 hour or after the 2 hours after the administration of tetracycline. Salt formation, as we discuss salt formation, the NH2 group on second position is involved in salt formation. Mainly acid salt is common. So here there is a tautomerism, double bond shifted here, hydrogen shifted here like this. Then there is the addition of HCl, hydrochloric acid, then it forms the hydrochloride salt. So this group is involved in formation of salt by tetracycline. So these are the main 4 properties. First property is epimerization. Second property is dehydration in presence of acid and in presence of base. Third, that is chelation property, and fourth one is salt formation. Then SAR of tetracycline. So here the general structure is given with the numbering. So numbering start from here 1, 2, 3, 4A, 5, 5A, 6, 6A, 7, 8, 9, 10A, 11, 11A, 12. Like this. Ring name is given A ring, B ring, C and this D ring. So first point in SAR, less than 4 ring inactive derivative. So here there are 4 ring. If we remove 1 ring, then the compound is inactive. Point number 2, 6-demethylated 6-deoxy tetracycline retain characteristic broad spectrum activity. It means that on 6th position, if we see here, on this one is 6th position. So here there is a CH3 group and there is a hydroxyl group in most of the tetracyclines. But if we remove methyl group, suppose if we remove methyl group on 6th position, then this compound is called as 6-demethylated compound. Similarly, if we remove hydroxyl group on 6th position, then it is called as 6-deoxy tetracycline. Similarly, if we remove both methyl group as well as hydroxyl group, then this compound is called as 6-methylated 6-deoxy tetracycline. So if we remove hydroxyl group and methyl group from the carbon 6, then the compound is called as 6-methylated 6-deoxy tetracycline, and this compound is also show the activity. Next point, fourth one, a replacement of amide group at carbon 2 with other function, maybe aldehyde or nitrile, reduce the activity. So on second position there is the amide group. This one is amide group. So if we remove this amide group by the aldehyde or nitrile, activities decreases. Next point, monoalkylation of amide nitrogen reduces activity. Amino alkylation of amide nitrogen are accompanied by Mannich reaction. So here this amide function. So monoalkylation means if we replace this one hydrogen of NH2 with the alkyl group or other group, activity decreases. So amino alkylation of amide nitrogen is accompanied by Mannich reaction. So here in case of Mannich reaction means it is a amino alkylation of acidic proton placed next to carbonyl functional group by using formaldehyde or secondary amine. So in case of Mannich reaction, this one hydrogen is replaced by the other alkyl group. So this reaction is utilized in formation of new tetracycline, that is Rowley tetracycline. So this one is Rowley tetracycline. So if we see here this NH2 group, here the one hydrogen is replaced by this group. So how it is formed? So it is a reaction. So suppose this one, so Mannich reaction means here the formaldehyde or amine group is required. So this one is formaldehyde, it is a pyrrolidine. So here pyrrolidine and formaldehyde react as shown by arrow. Lone pair attack here, it become O minus, then protonation it become OH, then removal of water molecule, hydrogen removed, bond shifted, double bond, OH minus, so it form imine. So it is a formation of imine. Then imine react with tetracycline. So suppose it is a structure of tetracycline which contains CONH2 group on second position. This R become the total structure of tetracycline. So here first step, there is in case of Mannich reaction, formation of imine compound. Then this imine compound react with tetracycline. So this NH2 group which is present on the second position of tetracycline react with this imine compound by this reaction. So here this pi bond attack to this carbon, this pi bond break, and there is a neutralization of this charge like this. Then there is a deprotonation, minus H, bond shifted here. So there is a formation of this type of compound. So RCONH, CH2, and this one is a ring. So here by this reaction, by Mannich reaction, one hydrogen of this NH2 group is replaced by this type of group. So example is, that is a Rowley tetracycline. So Rowley tetracycline is formed by the Mannich reaction in which pyrrolidine and formaldehyde react to form the imine compound. Then this imine compound react with the amide group of tetracycline which is present on second position, and then it form the Rowley tetracycline. Next point, sixth one, the dimethyl amino group at carbon 4 must have alpha orientation. So here this compound, that is this group, so in fourth position as we seen in epimerization reaction, the amino group, dimethyl amino group is attached through the dotted bond. In case of natural tetracycline, this NCH2 group is attached by the dotted, means alpha position. So it is important that this dimethyl amino group should be on alpha position. If we shift this group into beta position, then it gives epitetracycline which is less active than the natural tetracycline. So in short, natural tetracycline is more potent as compared to epitetracycline, because in case of natural tetracycline, this dimethyl amino group is on alpha position. In case of epitetracycline, this dimethyl amino group is on beta position. So it is about the, so here already given natural tetracycline. So here there is a dimethyl amino alpha position, here there is a beta position. So therefore natural tetracycline is more active than the 4-epitetracycline. Next point, ester of carbon 12A hydroxyl group is inactive with exception formyl ester. So in case of tetracycline, at this position carbon 12A position hydroxyl group is present. So if we form ester by using this hydroxyl group, then the compound is inactive. Next point, eighth one, alkylation at carbon 11A also leads to inactive compound. Ninth point, introduction of hydroxyl group at carbon 5 may affect pharmacokinetic property but not change antimicrobial property. So if we introduce hydroxyl group at carbon 5, so if we, for example, here there is a hydroxyl group at carbon 5, then there is a no decrease in activity but pharmacokinetic property is affected. So in both cases, here there is on fifth position there is a hydroxyl group. So here fifth position hydroxyl group. Example is oxytetracycline and doxycycline. So these are the potent compound. Next point, 10th one, which is important one. Neither 6 alpha methyl nor 6 beta hydroxyl group is important for activity. So as we seen in first point, there is a, in case of tetracycline, on this position, sixth position, there is a hydroxyl group and there is a methyl group in some cases. But if we remove methyl group from sixth position, then it is called as 6-demethylated tetracycline. Similarly, if we remove hydroxyl group from the sixth position, then it is called as 6-deoxy tetracycline. If we remove both hydroxyl group as well as methyl group from the sixth position, then this compound is called as 6-demethylated 6-deoxy tetracycline. So therefore, nor methyl group, no hydroxyl group is important for activity. So here see the example, that is metacycline, minocycline, maclocycline. So in case of metacycline, so here on sixth position, here we talk about the sixth position, that is R2 and R3, R2 and R3. So in case of metacycline, R2 equal to CH2 and R3 is no dash. Similarly, minocycline, R2 equal to hydrogen, hydrogen. In case of maclocycline, again there is a CH2. So in case of this three drug, on sixth position there is a no CH3 group, there is a no hydroxyl group. So this type of compound is called as 6-demethylated 6-deoxy tetracycline compound. So metacycline, minocycline, maclocycline is the example of 6-demethylated 6-deoxy tetracyclines. So this three drug does not contain methyl as well as hydroxyl group on carbon 6 position. 11th point, that 6-deoxy tetracycline and 6-demethyl 6-deoxy tetracycline have been used to prepare various monosubstituted and disubstituted derivative by electrophilic substitution at carbon 7 and carbon 9 of D ring. The more useful result have been achieved with introduction of substituent at carbon 7. So neither methyl group nor hydroxyl group of 6th position is required. So therefore this compound is called as 6-demethylated 6-deoxy tetracycline. So this type of compound is used to prepare new tetracycline. So for example, here strong withdrawing group such as chloro in case of maclocycline and strong donating group such as dimethylamino in case of minocycline enhance the activity. The metacycline is prepared by electrophilic substitution of metacycline. So the point here is that here we divide the tetracycline into two classes. First class is tetracycline, which contain methyl group as well as hydroxyl group on 6th position, and second class is the tetracycline in which CH3 and hydroxyl group is absent on 6th position. Then this compound is called as 6-demethyl 6-deoxy tetracycline compound. So this type of compound is used to prepare the new tetracycline. For example, here if you see here the doxycycline is not obtained directly from oxytetracycline, but we can convert oxytetracycline into metacycline, and then by reduction we can prepare doxycycline. So here if we see here oxytetracycline, so oxytetracycline on 6th position there is a hydroxyl group as well as there is a CH3 group. So in case of oxytetracycline on 6th position, hydroxyl group is also present and CH3 group is also present. So by using this oxytetracycline we cannot form the doxycycline. So it is not possible directly. So to overcome this, first we remove this hydroxyl or CH3 group. So here there is a removal of water molecule. Hydrogen is removed, this bond shifted here, it become OH minus. So it formed double bond CH2. So if that is called as metacycline. So you see here, in case of metacycline on 6th position, there is a no methyl group, there is a no hydroxyl group. So this type of compound is called as 6-dimethyl 6-deoxy tetracycline. Now so here there is an absence of hydroxyl as well as CH3 group. Now we can easily prepare doxycycline, simple reduction. So reduction means hydrogen added here, one hydrogen added here, pi bond break. So it forms the doxycycline. Similarly, due to absence of hydroxy and methyl group, this position is also susceptible for electrophilic attack. So on this position, chloro group easily we can put, that is meclocycline. So it is the use of 6-demethylated 6-deoxy tetracycline in preparation of new tetracycline. So metacycline, which not contain hydroxy and methyl group on 6th position, therefore we can easily prepare doxycycline and metacycline from this metacycline. So it is the importance of 6 hydroxyl group of tetracycline. So in short, if we see oxytetracycline which contain both hydroxyl group as well as CH3 group, so direct reaction is not possible to form the doxycycline, but we can easily remove these two group, hydroxyl group or CH3 group, to form the metacycline. So metacycline having double bond CH2 group on 6th position, there is a no hydroxyl group, there is a no methyl group. Then after reduction we can easily form doxycycline, and due to this CH2 there is a here easily attacked by the electrophile, therefore chloro group easily attack and it forms the meclocycline. Advantage of 6-deoxy tetracycline over simple tetracycline. So here what is the advantage of tetracycline which does not contain methyl group and hydroxyl group on 6th position, and this compound is called as 6-deoxy tetracycline. So what is the advantage of such compound? So as we seen in dehydration of tetracycline in presence of acid and in presence of base, hydroxyl group is involved, 6th position hydroxyl group is involved, but in this compound there is a no hydroxyl group on 6th position, therefore there is a no chances of dehydration of tetracycline. So advantage, first advantage, the 6-deoxy tetracycline are incapable of forming anhydrous tetracycline under acidic condition because they cannot dehydrate at carbon 5A and 6. So normally, as we seen previous, in presence of acid, tetracycline undergo dehydration and it forms the anhydrous tetracycline. So in that reaction 6th position hydroxyl group is involved, but here in case of 6-deoxy tetracycline compound there is a no hydroxyl group on carbon 6, therefore there is a no formation of anhydrous tetracycline and there is a no dehydration in presence of acid. Similarly, they also more stable in base because they not undergo lactonization to form the isotetracycline. So similarly, in presence of base, again 6th position hydroxyl group is involved, but here there is a no hydroxyl group on 6th position, therefore this type of compound not undergo the formation of isotetracycline. Next, the conversion of oxytetracycline to 6-deoxy tetracycline, there is a dramatically change the solubility. The partition coefficient of tetracycline and oxytetracycline is 0.056 and 0.075 respectively, while it is 0.95 and 1.10 in case of Deoxy and minocycline respectively. Hence, these drugs are absorbed more completely after oral administration and exhibit higher volume of distribution and lower renal clearance rate than corresponding 6-oxytetracycline. So it means that if we compare oxytetracycline, which contain hydroxyl group as well as CH3 group on 6th position, the partitioning coefficient of oxytetracycline is less, that is 0.56 and 0.75. But in case of 6-deoxytetracycline, so in case of 6-deoxy, in which there is a no hydroxyl group on 6th position, so therefore hydroxyl group is absent, then automatically lipophilicity increases, hydrophilicity decreases. So as we know, hydroxyl group is a polar group. So when the compound not contain hydroxyl group, it means that it is more lipophilic and therefore it has more partition coefficient like 0.95 and 1.10 in case of 6-deoxytetracyclines. So in short, 6-deoxytetracycline having the more partition coefficient as compared to the oxytetracycline. Fourth point, the non-polar substitution at position 6 or 7 further increase the partition coefficient. The poor oral absorption of more water-soluble compound tetracycline and oxytetracycline is due to difficulty in penetration lipid membrane. The polar tetracycline probably experience more complexation with metal ion in gut and undergo some acid catalyzes destruction in stomach. The more polar tetracycline are excreted in higher concentration in urine, that is 60% of tetracycline and 70% for oxytetracycline, than the more lipid soluble compound, that is 33% of doxycycline and 11% of minocycline. So in short, oxytetracycline and simple tetracycline, which contain hydroxyl group and CH3 group on 6th position, is more water soluble and less lipid soluble. But in case of metacycline and doxycycline or minocycline, which does not contain hydroxyl group on 6th position, therefore it having the more lipid solubility and less water solubility. 6th point, less distribution into bone. So this type of compound, that is deoxytetracycline compound, there is a less distribution into the bone. Although all tetracycline are distributed widely into the tissue, the more polar tetracycline have longer volume of distribution than the non-polar compound. The more lipid soluble tetracycline, however, distribute better to poorly vascular tissue. It is also claimed distribution of doxycycline and minocycline into the bone is less. So as compared to normal tetracycline, this type of compound, that is 6-deoxytetracycline, show less chelation formation and there is a less reaction with teeth and bone. So it is the advantage of 6-deoxytetracycline over the normal tetracycline. So it is about the tetracycline. So if you like the video, then subscribe the channel. Thank you very much.